Today we are going to go over Business Math A, Lesson 12. The objectives for this lesson are you will be able to model data with functions and find the best buy. You will also be able to evaluate bargain shopping algebraically. And lastly, you will be able to find good buys based on unit price. So let's go over some key terms. We have unit pricing, which is a technique that allows shoppers to compare the prices of various items. Sales tax, which is a state or local tax on the selling price of an item or service you purchase, usually expressed as a percent. Total purchase price is the total selling price plus the sales tax. Comparison shopping is comparing prices to find the best value. Comparing prices. Sometimes you want to compare price and find out which one is the best to buy. So remember, the cheapest one, also called the best buy, are the ones with the lower unit price. So there are some things you want to consider when you buy products. First, which one gives you a better price? We all want to save money, so we definitely want to take that into account. How large is the product? Is it 4 boxes of cereal or is it 2 boxes? You want to think about that if you have a family of 4 kids versus a family with just 1 kid. You want to make sure it doesn't expire and whatnot. You also want to consider, will the product you buy spoil or go bad if you buy a large quantity? So think about, do you plan on using everything in a reasonable time frame before the expiration date? So here are the steps to finding the best buy. So the first step is to find the unit price for each item. You can use the formula item price divided by the measure of count. We'll see what that means when we give an example. And the second step is simply just finding the best price based on what your answers are for step 1. So let's go and look at an example. So Jackie can buy 12 cups of noodles for $3.48, 20 cups of noodles for $5.40, or 50 cups for $11. So what is the best buy? So we want to find the unit pricing of each item. So let's look at 12 cups first. To find the unit price, you get the item price divided by the measure of count. The measure of count for that one is 12 because there are 12 cups of noodles. So we have $3.48 divided by 12. When you do that, you get 29 cents per cup of noodles. Now let's do the 20 cups. Same formula. We do $5.40 over 20. That gives us 27 cents for 1 cup of noodles. Last, let's do 50 cups. For $11, that gives us 22 cents per cup of noodles. So second step is to find the best buy. Looking at the unit price of each, we have 29 cents, 27 cents, or 22 cents. Mathematically, 22 cents is the best one because that's cheaper than 27 and 29. So the final answer is going to be 50 cups for $11. Alright, let's try another one. Jason can subscribe to Xbox Live for $59 a year, or $30 for 6 months, or $12 for 3 months. Last one, $5 for 1 month. We want to figure out what is the best buy. Same thing, find the unit price for each month. 12 months or a year. We want to make it into months because all the other units are months. So 12 months in 1 year. So I converted that. So that means it is going to cost you $4.92 per month if you decide to get the $59 subscription. Second one is 6 months. When you do that, you get $5 a month. The 3 months one, you get $4 a month. And the last one you don't have to do because it is already in the unit price of per month. The last one is $5. So even though I'm not writing it here, you want to keep that in mind when you compare the prices. So we have 5 there, $4.92 here, 5 here, and 4 here. So the best buy is going to be the one for 3 months because that's only $4 a month. Alright, choosing the better plan. So sometimes you have different options, whether it be phone plans, rental plans, or etc. For the most part, we don't really worry about phone plans anymore because it looks like all plans or a lot of plans are unlimited, but back in the day we have to do it. So I just want to mention that in there so that you can see how to do it mathematically, and you can always replace it with renting a boat, renting a car, or whatever. So you want to choose the best option based on the price and other factors you might have. You'll see what those factors are. So if you're given 2 different options, you want to create 2 equations because of 2 options. And if you have 2 equations, you want to have 2 variables. This is what we call system of linear equations. You should have learned system of linear equations in Algebra 1 and Algebra 2. If you have not, we're going to review it a little bit here or teach you a little bit here. If you still need help with it, feel free to reach out to me afterwards. So a system of linear equations is a collection of linear equations involving the same set of variables. We're going to use x and y in our examples just because when you learned it in Algebra 1, we mostly use x and y. Alright, so parts of a linear equation. The most common form of linear equation is what we call the slope-intercept form, and that is y equals mx plus b. We use that because you have a point and you have a slope. It's easier to plot that way. So m represents your slope, b represents your y-intercept, hence the name slope-intercept form. So slope is the rate of change or rise over run. The y-intercept is the point that crosses the y-axis, and for this class, it's basically our starting point. So here are the steps to solving a system of linear equations just for these examples coming up, not for every single one given in Algebra 1, for example. Alright, so step 1, choose the variables to represent each unknown. Remember, we're going to stick with x and y. Alright, next one, create the 2 equations for the 2 different plans, scenarios, whatever term you want to use. The third is to set the equations equal to each other, and I'll explain why later we have that third step. And the last step is to solve for the unknown. So here's an example. Marcus is comparing the cost of long-distance calling cards. To use card A, the cost is 60 cents to connect, and then after that, 7 cents per minute. To use card B, the cost is 20 cents to connect, and then 9 cents per minute after that. So how many minutes would Marcus have to use in order for the cost to be the same? So remember, first step, choose variables to represent each unknown. I'm going to use x to represent the number of minutes. Y will represent the total cost for card A and card B. So we have that. Second step, create the equations for 2 different plans. Let's do card A first. Card A, we know that the cost is 60 cents to connect and then 7 cents per minute after. So 60 cents to connect means 0.60 or 0.60 is your y-intercept, because automatically right off the bat you're starting off at 60 cents. Remember, your slope is your m, and slope is a rate of change. A rate of change is written with something per something else. that means your 0.07 is your slope. So this right here, first equation, is given in slope-intercept form, where 0.60 is your y-intercept, or your starting point, and 7 cents is your slope because it is 7 cents per minute. Y is the total cost. X is the number of minutes. We're going to do the same thing for card B. Except for this time, your y-intercept is going to be 0.20 because you're starting off at 20 cents. And then after that, it is 9 cents per minute. So anything with a per is a rate of change. The third step is to set the equations equal to each other. And remember earlier, I said that doesn't always apply. It depends on the situation. For this one, we set the equations equal to each other because it's asking how many minutes, which is x. We're solving for x. Would Marcus have to use in order for the cost to be the same? Cost to be the same means equal sign. If you were to put a symbol that represents cost to be the same, it is an equal sign. And that is why I use the word equal. So I substituted, instead of writing y each time, I set them equal to each other. So if you notice, this comes from the top, first equation, and this comes from the second equation. So because the question is asking how many minutes, we are solving for the unknown, which is x, because x represents minute. So that is the last step, step 4. So in order to solve for a variable, you want to use the opposite operation. So I want to get x on one side of the equation and then the constant on the other side of the equation. So I decided to subtract 0.07x to both sides of the equation. You could do the opposite and subtract 0.09 instead. It's really up to you. You should still end up with the same answer no matter what you decide to do. So I do that. So on the left side, it cancels out because 0.07 minus 0.07 is going to be 0. We're left with 0.60 equals 0.02. That comes from 0.09 minus 0.07 plus 0.20. So x is still not by itself. We have to use opposite operation again. This time I am subtracting 0.020 on both sides, giving me 0.40 equals 0.02x. What we need to do now is get rid of the 0.02. To do that, we divide both sides by 0.02, giving us x equals to 20. What that means is Marcus must talk for 20 minutes in order for him, or in order for the cost to be the same. So if he chooses to just talk for 20 minutes, it doesn't matter which card he chooses, it'll cost the same. So now we need to determine which one is the best plan. And for this scenario, this example, if he plans on talking for 45 minutes, we need to determine which plan is best. Is it card A or card B? So it all depends on the scenario. If he only plans on talking to 5 minutes, the option might be different. If he talks for 45 minutes, it might be different. And the way I like to find the answer is through graphing. So you can type this into a graphing calculator, these two equations, exactly like this. This would be the graph that you get. Alright, where the orange is card A and the black line is card B. So we're looking at 45 minutes. So 45 minutes is smack in the middle between 40 and 50. So I drew a line right there. So the best plan is the one that costs less, which means the one that is below the other. So if you look carefully, it is the orange line. The orange line is below the black line, giving us card A as the better plan. So if you don't have a graphing calculator, you can also just use the equations to find out. Right? Simply you know that X represent minutes. So what you want to do is plug in 45 for X right here. Instead of 45, instead of X, I put in 45. So now order of operation, multiply these two together and we get 3.15 plus 0.60, which gives us $3.75. So it would cost Marcus $3.75 if he were to talk for 45 minutes using card A. We would do the same thing for card B. Plug in 45 for X right there, and we would get $4.25 for card B. So 50 cents, not a big deal, but it is cheaper. 50 cents, still cheaper regardless. So that's same way we did earlier, or same answer as we got earlier. Both gave us card A as the better plan if it was 45 minutes. Alright, let's look at another example. So this time we have James having two different offers at two dealerships across the street from each other. So Honda is willing to pay him $1,500 per month. That's what we call base pay. And then $450 for every single car that he sells, or for each car that he sells. Toyota is willing to pay him $2,500 right off the bat, and then $350 for every car he sells after. So how many cars would he have to sell per month in order to make the same amount? So same thing as before. First, choose variables to represent the unknowns. X is going to represent the number of cars. Y is going to represent the monthly salary. So keep this in mind on how to determine what should be X, what should be Y. So X is your independent variable and Y is your dependent variable. So does the monthly salary depend on the number of cars he sells, or does the number of cars he sells depend on the monthly salary? As you know, we need to sell cars in order to increase our monthly salary, and that's why Y is your monthly salary. All right. Second step, create two equations for the two different plans. We have plan Honda, which starts off at $1,500, and that is your y-intercept, because right off the bat, or your starting point, is automatically $1,500, and then your slope is $450. Do the same thing for the second one, and you get 350x plus 2,500. So now we have two equations. We need to set them equal to each other. So we get 450x plus 1,500 equals 350x plus 2,500. Last step, solve for x. I am subtracting 350 on both sides, giving us 100x plus 1,500 equals 2,500. Subtract 1,500 on both sides, giving us 100x equals 1,000. Divide 100, we get x equals to 10. That means James has to sell 10 cars per month in order for his salary to be the same. Alright, now I want you to try one out on your own really quick. Pause the video and then resume when you are ready with an answer. Alright, same thing. First step, choose variables. So we have two different ones. First one is the total cost, and the second one is the number of hours. Right, number of hours and the cost. So the cost will depend on the number of hours, making the number of hours x and y equals to the total cost. Second, two equations for the two different plans. Store A is $5 to rent. That means right off the bat, it costs you $5. Even if you rent for 100 hours or 2 hours, right off the bat, you pay $5. That is your y-intercept, and your slope is going to be 2. Same thing for the second one. $8 right off the bat and $1.50 for your slope. Step 3, set the equations equal to each other. Step 4, solve for the unknown. Subtract 1.5x on both sides, giving us 0.5. X plus 5 equals to 8. Get rid of the 5 by subtracting. You get 0.5x equals to 3. Divide both sides by 0.5. X equals to 6. That means at 6 hours, the cost for the bike rentals will be the same. Alright, I want you to pause the video and then resume when you are ready. Alright, I have chosen to graph, but remember earlier I showed you how to use the equation as well. So again, it's really up to you. So this time we're looking for 7 hours, which on this graph is a little bit to the left side of 8. And remember, best plan means lower cost. So looking at that point, it's very close, but the blue line is lower than the A line, which means shop B is the better plan if Patrick plans on renting it for 7 hours. So you could, do the same thing. If you wanted, let's say Patrick wants to rent it for 3 hours only, you would look right here. And if you look at 3 hours, plan A, store A would have been the better one because A is lower. So use the graph to determine where you want to look at depending on your situation. Do you want to rent it for 5 hours versus 7 hours versus 10 and whatnot? Alright, here's one more. This one's a little bit challenging, but I want you to try it out anyways. Pause the video and then resume when you are ready. Alright, so we have time as one variable and then distance as the next because we're trying to catch up to Jennifer. So what is the distance before we get there? Alright, second step, create two equations for the two different scenarios. So we're going to do one for Taylor, right? So Taylor is at the starting point, and starting point is going to be 0 because we're right at the line of the starting point, and that's why there's no y-intercept. But if you want to write in the y-intercept, you can simply put 0 if it is easier for you. And the slope is the rate. right? So Taylor runs at 0.25 kilometers per minute. Next one is Jennifer. So because Jennifer has a 1 kilometer head start, right? Because Jennifer is 1 kilometer in front of Taylor, we have to add that +1 in there. And then the slope, or the speed in this case, is 0.15. We want to find how long would they catch up. That means where they would be when the distance is equal to each other. We're going to set them equal to each other and then solve for x. So subtract 0.15 on both sides, we get 0.10. X equals to 1. Divide both sides by 0.10 and we get 10. That means it will take them 10 minutes before they are next to each other while running. Alright, and that is all that we have for today. If you have any questions on any of these concepts, feel free to reach out to me.